how does it get to that synapse? You don't transport it, you make it. The brain is fixed, immutable, everything may die, nothing can be regenerated. That was the view of the brain when I started graduate school. I never really applied myself academically. I basically failed my first year in high school. And then I turned around because I met my future wife. So this year we will have been married 59 years on June 10th. I've been lucky. I've been really lucky. Just at the end of my first year as a graduate student, there was a discovery by a person named Jeffrey Reisman that was the first to show that after an injury to the brain, new synapses could form. It shook the foundations of the Cajal doctrine. All of a sudden, the brain turns into an organ that isn't fixed and immutable. It's plastic and can change in response to learning, experience, after injury. Very exciting. This is what I look like when I got my first job. And the importance of being a lifelong learner is it keeps your brain alive. That's the simple answer. I wanted to try to understand the mechanism. And so we did an experiment where it should have revealed increases in cell bodies of neurons. And what we saw was actually increases in protein synthesis in layers that were dendritic. We had also been doing studies with the electron microscope, and the first thing I saw were polyribosomes right beneath the synapse. It just popped into my mind that these ribosomes were making proteins, and those proteins were for the synapse that was right there. Something made here. How does it get to that synapse? You don't transport it, you make it. That's the finding. I did recognize that it was important. I believe it will lead either to the discovery of cellular mechanisms of spreading, or, dare we say it, information storage. Our discovery, I call it the origin story. Our key contribution was kind of getting it started. We're just on the threshold of a whole new dimension of understanding. And we're not there yet by any means. We're just scratching the surface.